So hello guys, so in this video I'll be talking about several design patterns that need to be that are relevant when you are writing microservices and deploying them to the cloud. Right, so writing microservices might be a simple task, but deploying them on the cloud involves more than writing code for the service. So you have to deal with several topics. So first is right sized. Right, is your microservices is that of the proper size so that it doesn't take too much responsibility. So what happens if it is not properly sized, it's more coarse grained, is that it will be much difficult to make changes to such an application. Right, then location transparent. So is the consumer, the client of the microservice can so has doesn't have the physical location hard coded in the application. So the location is transparent and multiple service instances could be started and shut down. Right, so then you have resilient. So how is your microservice consumers? How are you going to protect your microservice consumer a if you have a failed microservice that keeps them from from using their resources? How to prevent that? You need a fail fast approach for that. Repeatable. How does every instance of microservices guarantee to have a same configuration and code base? It is scalable. It has to be, you need to have asynchronous processing and event-based processing to minimize direct dependencies between your services. So based on that, we'll talk about different design patterns. So first is the core microservice design pattern. So we talk about service granularity. So your approach of decomposing the business domain into multiple loosely coupled distributed microservices. Does it each microservice has the right level of responsibility? If it is too coarse grained, then it will overlap several business domains, right? And if it is too fine grained, then it is really a dumb microservice which doesn't do anything more than reading the data required from the data store. And communication protocol. What are the protocols you're going to use? XML, JSON. We see that JSON is the ideal choice for sending and receiving data, sending and receiving data between microservices, and we will talk more about that. And interface design. So you have a so what is the interface, a service interface that you are going to expose? So developers have to use that to call your service, right? So you want to design your service URL to communicate the service intent. So well-defined intuitive service your design interface design is very important. Configuration management of service. How do you manage the configuration of the microservice so that it is consistent across different environments? And we also spoke about event processing, asynchronous and event-based processing, so the dependencies between microservices are reduced. Then we'll also talk about the microservices routing pattern. So you want to get abstract away. You don't want to expose the physical address of the services, right? So you need to have a single point of entry to the service calls. So that is where service discovery and routing comes into picture. So service discovery just means that your microservices is now discoverable. So so the client can find it without having to hard code the location of the service in the application. Right? And also, if microservices are misbehaving, then you can remove them from the pool of available microservices. Then you have service routing. So service routing is a single entry point of all the services, so that service policies and routing rules can be applied to multiple services and service instances. Right? So microservices, service client resiliency patterns. So you have because you have microservices highly distributed. So you have to be careful that a problem in a single service doesn't cascade up all the way to a consumer of the service. Right? So client side load balancing, which means that you have multiple instances of microservices or being or called or the client calls multiple instances of microservices, and how do you load balance them to the healthy instances of microservice. And circuit breaker is when your microservice is failing or it's degrading, then it tends to consume resources of your client. So how will you fail fast and respond quickly to such a scenario? Fallback pattern, when a service fails or degrades, then you have to have a plugin mechanism that allows the client to carry out work in an alternate means. So instead of try depending on the microservice that is now failed. Bulkhead pattern, it means that the distributed resources, multiple, so you have microservice applications, they use multiple distributed resources. So how do you compartmentalize all the calls so that one misbehaving microservice doesn't affect the rest of the application that uses distributed resources? The microservice security pattern, so we talk about security patterns, we talk about authentication, authorization, then we talk about OAuth and SSO. So how does the authentication? How does the service client? How do you know that the client who says he is what who he is actually? And authorization, how certain action that the client is going to take is uh, he is allowed to do that action. Then client management propagation. So how do you prevent a service client now from having to present its credentials rather than using which is an alternate to use OAuth or JWT tokens. Then you have logging and tracing. So the microservices, it is so distributed that in order to know what is going on with a certain service and its application, it could be a difficult task. So we look at the log correlation. So all the logs that are related to a transaction across several services can have a single correlation ID, and you have log aggregation where you can aggregate and put together all the logs for a certain transaction and use the correlation ID to help with searching what's going on with the service. And microservice tracing to visualize the flow of a client transaction and how to visualize the flow of client transaction across services. Right? So then you have the build and deployment. So you can't allow the configuration. You can't allow configurations to drift as it remains on the system for a long time. So you have to change your build and deployment pipeline. So microservices and servers run as a single unit of work. And how do you create a repeatable build and deployment that emphasizes one button builds, right? So that's what they are saying. So you have a repeatable build and deployment process. So to any environment, and you also have infrastructure provisioning of services also has as a source code to be managed under source control. Immutable services, once it is created, you cannot change it. Phoenix, when other service, there might be a configuration drift. So how you make sure that such microservices are drawn down and recreated with done the immutable image.